Great. Thank you all for coming again. We'll get going. So today, it's pretty amazing. Two of my favorite subjects that are on the board at the same time. It's going to be exciting. First, we have Stefan, who's going to talk about xylem in the gut microbiome. And after that, we have Andrea, who's going to chat a little bit about ChatGPT.
Awesome. Thanks.
Good morning, everyone. Can you hear me okay? Good. So I heard some chatter about ChatGPT at the beginning of the Coffee Break Science, so that's exactly the goal, to have an institute-wide conversation. So, of course, this is just a small presentation, but I hope we will carry on afterwards. And my interest for this topic started quite a while ago, in 2011, during my PhD, when I stumbled upon an American TV show I never heard of before called Jeopardy! And if you've never heard of it as well, it's a reverse pub quiz. Basically, the host will give you the answer, and you have to come up with the corresponding question. And the reason for my interest is that IBM sent as a contestant a massive computer called Watson. Let's have a look at how it played.
Now the last clue. Even a broken one of these on your wall is right twice a day. Watson.
What is clock?
Clock is correct. And with that, you move.
That was quite impressive. And yeah, you could see on national television the power of natural language processing. And some years later, in 2019, we had a leap forward with ChatGPT that gave better technology than that at our fingertips. So how did we arrive there? First of all, we should see what a language model is trying to do, because this helps demystifying the magic behind it. Basically, the task is to predict the next word of a text. And we have a very simple model embedded in the keyboards of our phones. It's usually called Ngram, and just can predict the next word based on the previous 2 or 3. So it's not very powerful, and as you know, it's not going to generate complete sentences. But it gives the idea. And there were problems at the time to try to scale it up and make better models. One of the problems is that it was processing words one by one, so you had to wait to finish processing one word to move to the next, and it had a very limited attention span, so to say. So it was forgetting the beginning of a sentence by the time it was reaching the end of a sentence. So how we happened to have ChatGPT in the end? It was thanks to a breakthrough paper published in 2017 by a team of engineers at Google called Attention is All You Need, where they introduced a new powerful thing called the transformer, that is the T in ChatGPT. So most machine learning algorithms start converting your input into numbers, vectors in this case. So we chop the whole sentence that we have in bits called tokens, and we encode it with vectors. And that's what all models do. The attention thing that Google introduced is a special layer where all these vectors talk to each other, changing each other's values. And as you can see, everything is processed in parallel. And this not only speeds up the thing, but also gives a better and extended context attention to the model. Then there are other layers called feedforward that are tuning the values within each vector. And if you stack a lot of these layers, apparently you can soak all the context and all the meaning of all the words and put it at the end of the last token. So to give you an idea, ChatGPT 3 has 96 layers of this. So when you get to the last token, you can do what you were doing with the Ngram algorithm and predict the next word of the sentence, in this case, Norwich. You put it back to the input, and you go on. And this is what ChatGPT does, and all the other language models. So it's not really magic, and we should remember this. This is the engine underneath the bonnet. But what I like about cars is that they don't need to be a mechanic to drive it, and so we can all use ChatGPT without knowing exactly the internals of it. But using AI with our natural intelligence, we can understand better how it works. So for example, this is a nice example. This is a prompt with a riddle where we ask ChatGPT a solution to this problem. 4 people need to cross a bridge. They have different speed, and the constraint is that they have to keep the slower person pace. The slowest person takes 10 minutes, so we should see that the answer is 10 minutes. And exactly as it happened with Watson, it's interesting to see what happens when these models are giving the wrong answer more than when they give the right answer. Because the answer is very long, very articulated, good looking, and very wrong at the same time. How is that? As I said, there is no reasoning in these machines, unlike the claims of some companies. And there is a massive training process where these models are reading, scanning a lot of text, basically the entire internet. So a very common HR question is more or less the prompt we gave with some extra constraints. The network recognized the pattern and went back to that solution and gave the right answer to the wrong question, basically. And this is the first thing. We should just remember that we have a powerful tool in our hand that can generate text that looks OK, but it's not necessarily correct. So we can make better use or bad use of it. For example, probably it's not a good idea to use AI in search engines, but I'm not one to tell Google what to do, actually. But one of the typical use of AI is to summarize text. And again, it gives the impression of being very good at it, because we usually don't read the long text, and we read the summary, and the summary looks OK. But some nerds that did try to check the accuracy of this process discovered that sometimes, again, LLMs cannot really get it right. And this is all because of what we saw. It's nothing magic. It's a very large model trained on a lot of text, and it's more or less OK sometimes. But we are in charge. We are the users. And I love this slide from 1979, an internal presentation at IBM, where they said, a computer can never be held accountable. Therefore, a computer must never make a management decision, or any decision, maybe, like driving cars. So what's the use that we can do in research? I think we have a lot of opportunities with LLMs, and we have really good opportunities if we take some time in understanding how they work and how we can embed them in our workflows. Because some people, I think, got a bit too enthusiastic about the power of this tool and ended up, as you probably know, publishing bonkers images and a lot of AI-generated text without even polishing it. This raises questions about peer review as well. There is another aspect, that the tool itself is this massive network of numbers being mangled, but they are also hosted in companies' servers. So we have a confidentiality issue. Most of the text we would like to analyze with LLMs, we can't really put it in ChatGPT or Claude. According to OpenAI themselves, please don't share any sensitive information in your conversation, and they write it in a place where they know no one will read it. So, I mean, they benefit a lot from us interacting with LLMs. It's called fine-tuning, and all our data is really important so that we are offered a free tier of these services, basically. But this calls for the use of local AI. We can implement and use local models. There are a lot of free models that you can download and implement. And because they are local, the information we give to the prompts doesn't leave our servers. And these are bricks that we can use to do more advanced research. So for example, there's a tool called Oyama that can serve local models to either chat-like interfaces, or we can just use them as bricks in any kind of research we want to do. These are screenshots, so you can see both a ChatGPT-like interaction from the command line or from a website that really looks like ChatGPT, but it's local. So I think this is something that we should explore more, and in Quadram Informatics we are trying to do this, and we will do this in the next month. And just because I really believe in the potential of these tools, I want to show at the last of this presentation a small sequence from an agent. This is a coding agent where language models are using to automatically improve your code, test it, challenge it, and as long as you know what you're doing or what the LLM is doing, you can get a boost in productivity and probably better code at the end, because you don't get tired of adding annotations, comments, and so on and forth. So concluding, I think you all know that we should use AI critically and that we need to be very careful with sensitive data. But at the same time, I'm quite excited about the potential, and I would like to test and experiment with these tools and possibly do it together. And maybe we'll organize hackathons or data science meetings about this. And in general, let's chat about it, because I'm sure a lot of you have good suggestions on how to make better use of these tools. Thank you for your attention. And now, before handing over to Alison, who will guide us through the news, I will start with a couple of news from Quadram Informatics. The first is that you probably know we are migrating to a new cloud. And because of space and cooling constraints, we cannot have both the old one and the new one operative at the same time. So we will have quite a complicated transition. And if you are using the cloud and you need help or guidance during this transition, please reach out, and we are very happy to help you in this. Next up, we would like to improve the outreach of our dataset. QIB produced a lot of interesting data sets over the last years, and if we make them better annotated, more interoperable, they become more discoverable, we improve their impact. And so we organized a couple of workshops about FAIR data, where the idea is that come with your published data set, and we'll try together to find a way to make it more discoverable and better annotated for the community. And finally, a very good news from the CLIMB project that, as you know, provided computing capacity for the UK, and it was a funded project that ended in March. But now it starts a second phase with a self-sustainability plan, and we are excited to say that Nick Lohman is joining QIB part-time to be the director of CLIMB, assisted by Lisa Marcioretto as operation manager. And now I can hand over to Alison.